Welcome to level 1 linear equations. So let's start doing some problems. So let's say I had the equation 5, that's a big fat 5, 5x equals 20. So at first this might look a little unfamiliar for you, but if I were to rephrase this, I think you'll realize this is a pretty easy problem. All this is the same thing as saying 5 times question mark equals 20. And the reason why we do the notation a little bit, we write the 5 next to the x because when you write a number right next to a variable, you assume that you're multiplying them. So this is just saying 5 times x, so instead of a question mark, we're writing an x. So 5 times x is equal to 20. Now most of y'all could do that in your head. You can say, well, what number times 5 is equal to 20? Well, it equals 4. But I'll show you a way to do it systematically just in case that 5 was a more complicated number. So let me make this my pen a little thinner. Okay. So rewriting it, if I had 5x equals 20, we could do two things, and they're essentially the same thing. We could say we just divide both sides of this equation by 5, in which case the left-hand side, those two 5's will cancel out, we'll get x, and then the right-hand side, 20 divided by 5 is 4, and we would have solved it. Another way to do it, and this is actually the exact same way, we're just phrasing it a little different. If you said 5x equals 20, instead of dividing by 5, we could multiply by 1/5. And if you look at that, you can realize that multiplying by 1/5 is the same thing as dividing by 5, if you know the difference between dividing and multiplying fractions. And then that gets the same thing. 1/5 times 5 is 1, so you're just left with an x equals 4. I tend to focus a little bit more on this because when we start having fractions instead of a 5, it's easier to just think about multiplying by the reciprocal. Actually, let's do one of those right now. So let's say I had negative 3 over 4 times x equals 10 over 13. Now this is a harder problem. I can't do this one in my head. We're saying negative 3/4 times some number x is equal to 10 over 13. If someone came up to you on the street and asked you that, I think you'd be like me and you'd be pretty stumped. But let's work it out algebraically. Well, we do the same thing. We multiply both sides by the coefficient on x. So the coefficient, all that fancy word means, is the number that's being multiplied by x. So what's the reciprocal of minus 3/4? Well, it's minus 4 over 3 times, and dot is another way to use times. And you're probably wondering why in algebra there are all these other conventions for doing times as opposed to just a traditional multiplication sign. And the main reason is I think just a regular multiplication sign gets confused with the variable x. So they thought of either using a dot if you're multiplying two constants, or just writing it next to a variable to imply you're multiplying a variable. So if we multiply the left-hand side by negative 4/3, we also have to do the same thing to the right-hand side, minus 4/3. The left-hand side, the minus 4/3 and the 3/4, they cancel out. You could work it out on your own to see that they do. They equal 1, so we're just left with x is equal to 10 times minus 4 is minus 40. 13 times 3, well, that's equal to 39. So we get x is equal to minus 40 over 39. And I like to leave my fractions improper because it's easier to deal with them. But you could also view that that's minus, if you wanted to write it as a mixed number, minus 1 and 139. I tend to keep it like this, though. Let's check to make sure that's right. The cool thing about algebra is you can always get your answer and put it back into the original equation and make sure you were right. So the original equation was minus 3/4 times x, and here we'll substitute the x back into the equation. Wherever we saw x, we'll now put our answer. So it's minus 40 over 39, and our original equation said that equals 10 over 13. Well, and once again, when I just write the 3/4 times right next to the parentheses like that, that's just another way of writing times. So minus 3 times minus 40 is minus 100, and actually we could do something a little bit simpler. This 4 becomes a 1, and this becomes a 10. If you remember how when you're multiplying fractions, you can simplify it like that. So it actually becomes plus 30, because we have a minus times a minus, and 3 times 10, over, the 4 is now 1, so all we have is left is 39. And 30 over 39, if we divide the top and the bottom by 3, we get 10 over 13, which is the same thing as what the equation said we would get, so we know that we got the right answer. Let's do one more problem. Minus 5, 6, x is equal to 7/8. And if you want to try this problem yourself, now's a good time to pause, and I'm going to start doing the problem right now. So, same thing. What's the reciprocal of minus 5, 6? Well, it's minus 6 over 5. We multiply that. If we do it on the left-hand side, we have to do it on the right-hand side as well. Minus 6 over 5. The left-hand side, the minus 6 over 5 and the minus 5, 6 cancel out. We're just left with x. And the right-hand side, we have, well, we can take we could divide both the 6 and the 8 by 2. So this becomes negative 3. This becomes 4. 7 times negative 3 is minus 21 over 20. And assuming I haven't made any careless mistakes, that should be right. Actually, let's just check that real fast. So minus 5, 6 times minus 21 over 20. Well, that equals, on this 5, we could make that into 1, turn this into a 4, make this into a 2, make this into a 7. Negative times negative is positive, so we have 7. 2 times 4 is 8, and that's what we said we would get. So we got it right. I think you're ready at this point to try some level 1 equations. Have fun.